Hi, everyone. My name is Adam Trunco. I am a member of the LunaSat team with Glee, and I'm going to be introducing you to the LunaSat. So just some quick facts about the LunaSat. On the right, you can see a picture of it. This is our latest version, the V5 dot workshop remote. Essentially, the dimensions here, it's a 61 by 61 height and width in millimeters. And then in terms of thickness, it's 2 millimeters. So that includes all the sensors, the solar panels, everything like that. Currently, the mass is 20 grams with all the sensors and components and everything like that. We will be decreasing that in the final version. Our power supply, everything mostly comes from the solar panel, which you can see at the top there. So that's where we're able to get all of our power from. It can power all the sensors, everything like that. Our operating temperature range on the moon is -30 degrees Celsius to 80 degrees Celsius. So it gives us about 110 degrees of temperature to work within. And on the moon, it can operate a total of 6 lunar hours, which is equivalent to about 5.9 days on Earth. So a pretty wide range of operation. Some fundamental principles behind the LunaSat. It's easy to use, which is really good for really everyone, us when we're manufacturing, and then everyone while they're using it. It is low cost. We're able to order all of our parts online, and we're able to manufacture pretty easily. It is durable, small form factor. It is a square, so it does give us that pretty sustainable form factor. Valuable. It'll record valuable scientific observations for us, specifically with all the sensors we have. It'll give us a lot of readings on temperature, moisture, radiation, everything like that. And we'll be able to take that data and then transmit it back to the lander so that we can then read in the data and essentially see everything that's going on the moon. So just a quick component overview. The main components, as you can see here, number one is the Atmega 328 microcontroller. We'll get into it a little bit more later, but essentially this is the brain and the heart of the LunaSat. It's able to kind of reach out to all the sensors and kind of control everything. Some of the sensors, there's a temperature sensor, a magnetometer, accelerometer, a thermopile, and there are capacitive sensors. Again, we'll get into those later. In terms of power, like we said previously, there's the solar panels, but then also there's the PMIC, which is the power management integrated circuit. This kind of takes in power and converts into a usable voltage for us so that we can then operate within the range that we need to. And then for RF radio frequency, this is how we communicate between other LunaSats and then with the lander itself. And essentially there's a transceiver and a receiver, and then there's also an antenna as well. And then just some other components there are pin headers. This allows us to test, connect to our laptops. Allows us to read and code, kind of take in data and see if everything's working, things like that. And then there are also LEDs, which kind of similarly for RF, this allows us to see if everything's communicating. If they can communicate with between each other, then the LEDs will blink. So those kind of things like that. And then next, we're going to get into actually identifying these components and going into more detail about each of them.